don't test with too many variable changes at once. You change one variable, test. Because you change 5 variables and you don't know what fixed it.
Hello and welcome to the Being an Engineer podcast. Today we have the absolute pleasure of speaking with Noah Burke, a certified SolidWorks professional and accomplished mechanical engineer. Noah's journey has taken him from hands-on roles in design and assembly to his current position as a product design engineer at Colson Group, USA. Notably, Noah was also a valued member of our team here at Pipeline, where he consistently demonstrated exceptional skill and dedication. Noah, so fun to be able to talk to you again. It's been, maybe a year or so, something like that. And it's just really nice to see your face and hear your voice. Well, what made you decide to become an engineer, Noah?
It's funny, somebody asked me this about a week or two ago, and it was really, really early on when I was pretty young. Math and science were always my, they came pretty easily to me. Grammar and spelling, we're still working on that. One day I'll get there.
I can attest to that one. Yeah.
Yeah. It's, if you give me a formula, got it. But yeah. So math and science came pretty easy to me, and I knew, that was heavily involved in being an engineer. A couple of my parents' friends were engineers, and they kind of really spoke highly about them. And everybody I talked to spoke highly about, knowing an engineer or so-and-so is an engineer. And being around, engineers, I didn't really know what they did. They seemed to kind of stand a little taller, and they were just a respected individual. And they did math and science stuff. So I was like, well, I can do that stuff. So let me give a crack at being an engineer. So really early on, I decided to give it a shot. I think my sophomore year in high school is when I took my first CAD class. And CAD came pretty quick too. And so I went out to the Jackson Area Career Center for 2 years, and that rolled into my first job doing CAD and getting to see, automation and what, engineering is actually applied. There's a good amount of people that go through school all the way through college without getting that on the job look at things. And I think that's pretty crucial to see it up front and know, okay, this is something I want to do.
Yeah. I can also attest to the fact that you are very talented with CAD. I mean, from the day that you were hired, you hit the ground running, knew exactly what you were doing, and only got even better as time went on. I think AccuBuilt was your first job, real job working as an engineer. Is that accurate?
Yeah. Yep.
Okay. So you did a bunch of assembly there. You did CAD as well, but I think you did quite a lot of hands-on assembly work. How did that hands-on assembly work and that experience influence your approach as a designer?
That's been a pretty big influence of really stepping through of how we're going to get this together, because you can design a lot of things in CAD world that you can't make and you can't assemble. And in the beginning, you could run some of the interference checks and, it all checks out. That'll be good. And then you get into it, when things are moving, specifically in automation, if there's a bolt head in the way, carriage smacks into it, that's going to be a big problem. So that's one of the best ways to learn, is to take those designs and walk them into the real world and see the mistakes. Some, could be major, some could be little things. Like if a bolt head's hitting, we just have to counterbore it, right? And it'll be tucked away. But, whole plates could be incorrect. At AccuBuilt, we used a lot of shims, which was nice. So there was a little forgiveness. But hands-on and seeing how much work goes into the things you design too, right? Because in CAD, you just float stuff in there and you put mates on it and you get faster and faster doing that. But your CAD level, as it increases, you can go a lot faster than anybody can put it together. So what I've learned, thanks to the great people at Pipeline, specifically Mike, it's good to slow down. I would get so fast and I'd overlook little things. So slowing down and taking a second and just sitting there, it might not look like you're doing anything, just staring at the screen and zooming around at stuff. But it's really crucial. It saves you a lot of time and money to fix stuff in CAD versus fix stuff in real life.
Yeah, I think that's a big point. There's a significant difference between action and progress. And I think a lot of us have a tendency to just perform action, right? We just want to do because we know something we could do, so we do it, as opposed to sitting back and thinking about, all right, let's try to project, 3-4 steps into the future. Is what I'm doing now going to facilitate an efficient process moving forward, or are there some things that I should be changing right now so that I make my future life a little bit easier? So as you know very well, here at Pipeline, we do manufacturing processes and automated machines and custom fixtures. Can you think of a project, whether it was at Pipeline or somewhere else, but that was particularly challenging for you and how you overcame those challenges?
There's a lot of them to pick from. That was one of the fun things, is the challenge. So, if everything was the same and everything was easy, everyone would do it. And having that challenge, and some of the projects that we would get at Pipeline were especially fun because people would say, we've tried to do it and we can't find a way. They would come to Pipeline for help. And so that just was extra drive to, okay, how can we figure this out? It was great brainstorming with people. I really like doing that. Me and Mark. One of the ones that I'll touch on is the trim and punch prototype. So it was a really small distal tip, and we had to find a way to remove this heat shrink wrap and puncture it with a mechanical device, because if you did anything with a laser, it produced toxic fumes. And Mark and I, we actually ended up having such a good brainstorming session, we stayed a little over, just thinking about all these crazy ways we could, okay, they're going to load it like this, and then what's going to happen next? And it's all going to be mechanical, and we got to find a way to poke yoke it. And we ended up on this little magic box. And, part of the reason why I've gotten so much better at CAD, especially working, during my time at Pipeline, is because there was great people around me. Mark was one of them. John's one of them. Aaron doesn't do a ton of CAD nowadays, but I'm sure he's real good too. And so I think it was the next day or the day after that, Mark's like, hey, check this out. And he has got like a moving mechanism going on with the planetary gear and cams and bearings. And I'm like, wow, it was, really early on at my time at Pipeline. I was, okay. I didn't do a lot of the hard work there, but the figuring that stuff out, that brainstorm session, and then eventually we incorporated a e-stop mechanism on it. So when they punched the device, it would stay locked, and you weren't able to unlock it until you turned this handle and it cut the heat shrink. And then once it cut, it would pop up and it would allow the operator to unload it. So, working with somebody else to mold those two ideas together, when you work with different people in CAD, you find ways, 1,000 ways to skin a cat. There's probably 1,000,000 ways in SolidWorks. So find all these unique ways that they do something that you never would have thought of. And then you think, oh, that would be really good for this scenario and that scenario. So that one really sticks out to me, because that was kind of the eye-opening. Oh, wow, like we're doing some pretty crazy stuff here.
I remember that one as well. It was mechanically beautiful. I mean, it was a work of art, and a black box is a good way to describe it, because from the outside you couldn't really see all the intricate mechanisms that were going on. But yeah, it was a work of mechanism art for sure. Let's see, transitioning to the Colson Group, which is where you are now. what are some of the things that you're enjoying most there in your current role?
My current role, it's new product development of products, right? And at Pipeline, this was another great thing about Pipeline is it could be automation, it could be product development. There was a mixed bag. So you kind of jump back and forth, which is awesome. Now it's mostly pretty much all product development. So honing in on products. So a lot of times we'll take, we're getting customer requests for a specific thing that, the market wants. And some people want one extreme, there's that bell curve, right, of possibilities that you could design for. And so really honing in on what product is going to help the most amount of customers and they're going to purchase. So finding a way to, whether that's make things adjustable or designing multiple configurations right from the get-go, different top plates and things like that. So it's much more product oriented now. But my time at Pipeline, being able to ask the customers the questions, right? Because a lot of times you're not talking to a technical, engineer on the other side. You're just talking to somebody and they're like, I want it like this. And so you have to, okay, so how can I ask them a question and be able to get a lot of information from that answer, more than just the answer to that simple question. It could be, if I ask this question, I can get an answer to 3 questions. Mm-hmm. So being able to talk with them and ask those questions. And, if you're talking to somebody who's not the best with technical stuff, simplifying it and you can, gather information from that too. They might not be able to say, we need our spring rate to be this and it needs to be dampened this well and it needs to be, have steel this thick and it needs to be this material type. But you can ask questions to kind of get that information from them. Is it going in the clean room? How much weight are you putting on this cart? Things like that.
I think that's such an important skill to have, is knowing how to ask good questions. I noticed this with salespeople a lot, and I know we're not, this is not a podcast about sales, but in a way, we're all salespeople. We're all trying to sell, something, our ideas, our philosophies, whatever they are, engineers included. And the best salespeople that I've worked with don't just talk at me. They ask me thoughtful questions and they listen to my responses. And that's what guides the conversation. And I've found that that's rare. Most salespeople and just people in general don't ask you many questions. They tell you what they want to tell you, right? Here's the feature that this product has, and here's the warranty that it has, and here's why it's so great. Well, okay, that's all fine and well, but you don't even know what I'm looking for because you haven't asked me any questions. So I love that you're talking about questions, and it's just such an important skill for an engineer or anyone to have, to get really good at asking thoughtful questions.
Yeah, I totally agree. I read a book, I can't remember the name, read a book recently that talked about, kind of soft leading, right? Not barking orders or demanding answers, but asking those questions to get the information that you seek in a soft way, right? Because if you bark or demand, people don't like that, right?
Yeah, right.
You might get what you want, you might get it fast, but after they give you the information, they turn around and they're like, I did not enjoy my time working with you, right?
Yeah.
And then they go somewhere else. And
might burn the relationship.
Exactly. Don't want to do that.
You have your certified SolidWorks professional certification. How has that impacted your career or just your design skills in general? Like, what has that done for you? And do you recommend it to other engineers who are working in CAD?
Yeah, I do recommend it. It's it is something that can go on the resume. I have it on my resume, and some people might not know what it is, but it does show that you know, had the skills to attain it, right? And the professional one, it was challenging. I studied for it for a while, and it gave me a new look, right? Taking these practice exams and doing really complicated part geometry and things like that. If you are going to take it, I recommend watching the RCM videos and learning a bit about that, because that can be really helpful. One of the things they do in the exam is they have you design a part, and then they have you change certain things. And depending on how you designed it, those changes can blow up everything, or they can be a seamless transition, right? So RCM really helped me out.
And RCM stands for Resilient CAD Modeling, and that's a methodology that we didn't actually develop, but maybe refined the process a little bit. And we have a tutorial about the RCM process and everything start to finish on the wave.engineer that you can access for free.
Yeah, that's a great resource. It's only going to improve, right? It's going to give you a new way to look. One of the 1,000 or a million ways to skin a cat. But there's a lot of other stuff, because the PDM stuff that I got to be a part of at Pipeline, macros. Mark is great with macros. I'm nowhere near Mark, but even being able to learn from him some of the small stuff, I've been able to build little macros to take away, little things that will drive you crazy, right? If you're on a computer for a long time and you're doing repetitive tasks, it's like, man, it can get at you. But yeah. I highly recommend it. I've been gearing up to start taking I believe it's 3 or 4 that you have to take before you can do your CSWE. So I've been getting back in and studying things like surfacing stuff. I've not used that before. So things like weldments and sheet metal, I've used that quite a bit, but some of the other stuff like surfacing, I'll have to study up on pretty good.
Yeah. I know when I see it on a resume, it always piques my interest. It's a positive. If I see that on someone's resume who's applying for a job here, I always think, oh, that's nice to see. And, all else being equal, I would take the person who has that certification over the one who doesn't, because it does show a certain level of not just skill or capability, but initiative as well.
Mm-hmm. Yeah.
Can you think of a time when your work directly contributed to improving either a product's performance or maybe even a user's experience with that product?
Yeah, we had a project was a pipeline. It was a mechanism that kind of works similar to a Kleenex box. And the customer had brought it to us. They said it was a prototype, but they had invested a lot of money into tooling, and the product wasn't functioning how they wanted it to. And so I got assigned the project, and I looked at the product, and working with other engineers and interns, we developed a test, designed a fixture to do the test, carried out the test, analyzed the data, and we were able to replace an off-the-shelf part opposed to altering any of the injection molded parts that would allow this fancy Kleenex box, it wasn't for Kleenex, it was for some other stuff, to actually dispense how it was originally intended. So what was probably a big worry for the customer of, oh man, I spent so much money on tooling and our product's not where we need it to be. How much more money am I going to have to invest in changing that tooling before we can actually start selling these, because it's something we're proud to sell. So just switching out that little spring made it function how it was originally intended. And I know the customer, had a big sigh of relief and said, thank you so much. Something so little, right? The spring cost was so negligible, right? When you're talking about changing tooling.
Yeah, right. Yeah, I remember this project as well. All right. Well, let me take a short break here and share that the Being an Engineer podcast is brought to you by Pipeline Design and Engineering, where we don't design pipelines, but we do help companies develop advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services. You can learn more at teampipeline.us. The podcast is also sponsored by The Wave, an online platform of free tools, education, and community for engineers. Learn more at thewave.engineer. And today we have the privilege of speaking with Mr. Noah Burke. Noah, can you share an experience where you had to troubleshoot a design issue during the manufacturing phase? So ideally, we work out all the kinks and bugs in the design, prototyping, kind of R&D stage. But, that's not always the case. And every now and then something slips through, which is normal and expected to some degree. And so tell us, what was the problem? And how did you resolve it? Something that you had to troubleshoot during the manufacturing phase.
Yeah. Again, there's more than one to choose from, because like you mentioned, always something that sneaks through. One of the ones that I remember, it was a desktop fixture, and it was a remake of an old design. And so in this old design, they had only, there's knobs on this device that they would load into the fixture. And originally they were only driving one of these knobs to test it out per cycle, and they would change to a new knob. And this new fixture had all 5 knobs driving at once. And so there was a lot going on. There was a motor per knob. We looked at doing it mechanically, and it was cheaper to just go a motor per knob. And then working with the controls engineer to get all that functioning correctly. There was, changes we had to make to the motors to get the correct motors in there. Originally, I had spec'd out motors that weren't the best for the application. So I had to make mechanical changes to the brackets, then make sure all the belts are in there. And once that was going on, controls, there was some problems with spinning. So we had to dive into it and see, is this a mechanical thing that's causing this issue or a controls thing? And so, it gets, when you get in there, you can kind of get frustrated. You're like, oh man, I was supposed to work. I thought I'd crossed all my T's and dotted all my I's, and what's going on? And so for me, it's important to take a breath. Okay, let's run a cycle and let's just see and think about it. And then, introduce some variable. Brandon, who was around kind of in my first half of, when I was at Pipeline, he shared some great knowledge with me. Don't test with too many variable changes at once. You change one variable, test, because you change 5 variables and you don't know what fixed it. So that came in handy there, and we were able to pinpoint the problem and then fix it without any, major redesigns. But that was one that sticks out to me.
Yeah, that's great advice. Don't change more than one variable at a time when you're troubleshooting. I've run into that myself. I remember a long time ago, I read a book about engineering or manufacturing. I can't remember exactly what the title of the book was, but there was this table in this book, and it talked about the cost of fixing a design flaw at different parts of the product development life cycle. So I don't remember, I'm going to mess this up a little bit, but you'll get the idea. So if you found a design flaw early in the design phase, it was like 1x, just not a big deal. If you found a flaw late in the design phase, it was like 10x. If you found a flaw after parts had been manufactured and you received them, it was like 100x. And then if you found a design flaw once parts had shipped to the customer, then it was like 1,000x, right? So it was like this increasing scale of magnitude every time, or at each subsequent phase of a product development and launch cycle. And that always stuck with me, just how much more expensive it gets the later in the design phase or the development phase that you identify these problems. So it might feel like an overkill to spend so much time during the design phase, the early phases of a development project, to bring people in, cross-functional teams, have all these eyes on it. But man, it saves so much money if you spend a little bit more up front and make sure it's right before going into production and shipping product out to customers.
Yeah, totally agree.
What are some of the emerging or even maturing trends in product design that you think engineers should be aware of, especially younger engineers?
One of the kind of the most prominent, and I think even a lot of people know about it, right? It's 3D printing. And I tell especially the younger kids that I help teach and mentor, you got to pay attention to 3D printing because there's a lot of money being spent in development. I didn't get into it until 3D printers were pretty well developed, but you can look back on YouTube and see some of the, probably 10, 15 years ago, the first 3D printers. And, they were more of a tinker toy than a printing, reliable printing device. It was changing and adjusting settings, but thankfully it's a lot of open source, right? And they've been able to develop that crazy fast, where now you have printers, you send it a file wirelessly, it's got a video camera on it so you can monitor it, and it's super fast, so you get what you designed, and you just go pop it off the bed super easy, and you can put it together and test, whatever you design, whether it's a mechanism or, just a trinket that you designed. So 3D printing is awesome. I love to play around with materials, specifically in 3D printing. They have like metal powders, and now they have metal printers where they're like welding a bead around, FDM metal printers and sintering metal printers. And so right now those are super expensive, but as the technology continues to grow, it's only going to get cheaper. And now, a lot of companies have FDM plastic 3D printers. It's pretty much the norm now, right? But 10, 15 years ago, they would have laughed at the idea of putting in a tinker toy, right, into their, and called it like a way to get products out the door faster. So that's one of them that I'm definitely excited to see where it goes. But there's a lot of stuff that comes out pretty frequently. Seeing trade show videos and product demonstrations is awesome. LinkedIn is a great source. Scroll through there and you see some awesome stuff. I like to just, every once in a while when I hop on McMaster Car, I just scroll around and see what new things they've added. I remember during my senior year in college, I had found this little detent, but instead of like a plunger detent, it was a directional detent. It kind of looked like a little balloon. And when you would push it one way, all it would try and do is return to center. And we were considering using it for our design, and I showed it to the senior design director. He's like, I've never seen that before. That's pretty cool. And how did I find it? Just scrolling all around on McMaster Car, looking for, whatever was out there. And McMaster Car's one, Automation Direct, Masumi. There's a lot of, suppliers that, they're constantly looking for good things to add to their catalog. So as far as, scrolling down a couple lines sometimes, or, reading a newsletter here and there to catch something new.
Great advice. Great advice. One thing I always appreciated about you during your time here at Pipeline was that you always had some other project going on, like a personal project, and it often involved 3D printing. But I loved seeing that your hobby was engineering as well. you know? And even within the context of your actual job here, you were never content to just do the minimum. You always went that extra step. Sometimes, like you mentioned with you and Mark brainstorming, it led to spending, a few more hours past the typical 40-hour work week. But you always went that extra step, always went that extra mile. And you were tenacious at finding solutions. Where do you think that drive comes from? It seems to me that it was never to satisfy anyone else. It was never to like, oh, the optics of me working a few extra hours are good, so I'm going to work a few extra hours. It seemed like it was more of an internal motivation. And I'm just curious if you've ever thought about like, where does that drive come from?
I think maybe I should spend some more time thinking about it. But I think I really chose the right path for me. You hear stories of friends that went to college and they graduated college and they don't like what they do at all. And I'm so far in the opposite direction. And I just feel so bad for people, that struggle to find what they really like to do. And I really like to, do projects, right? Whether they're personal projects. If it's a personal project, I want to make the best thing possible for myself, right? A lot of things like, I use this a lot, opposed to buying, a cabinet off of Amazon or Wayfair, I would much rather spend double or triple the amount of money and buy the wood and make the cabinet myself, because you get to add, your personal flair to it and design it just the way you want it. And then, at work, you're doing a customer's project, but it's still your brainchild, right? And you want it to be the best thing, right? You want to hear back from the customer and hear, I love to use this so much. And I can't wait for the next time we get to work with you and Pipeline at the time. So that's what really drives me is, building something I love for myself and build something that people love to use. Because, if you just want to skate by and do the bare minimum, that's fine, right? All the requirements are met. Customer gets it. How's it work? Well, it works fine, but, this is kind of floppy over here. It's not like the most robust thing. And, this is kind of in the way and we didn't notice at the time, but it does what it needs to do. It's okay. And I don't want it and it's okay. I want, wow, that's pretty cool. And that's super nice and super slick. And, you can tell that somebody took care in what they were doing and thought about it a little bit extra. And I think it's easy for me to do that because I like it so much that it's like, you're driving home, I'll be listening to music or listening to a podcast and, oh, how could I make that better? And it's not like a, nagging because, your brain is like reminding you, oh, because of immense work pressure that you need to get this done. And if you don't get it done, you're going to be on the frying pan. No, it's oh, well, my brain's kind of not thinking about much. And all of a sudden, what if I tried doing that? Could that be better? And just playing around with those ideas, I find to be great. So.
Well, I think you hit the nail on the head when you said that you chose the right path for you, right? And you just love doing this stuff. So it doesn't feel like work. It's recreation. It's play. Mm-hmm. It's something to tickle your brain. Love it. Any advice that you would give to young engineers who are interested in entering the field of product design and development?
Yeah. Learn CAD and use it to do all the things. So a lot of like I mentioned about companies with 3D printers, a lot of schools have 3D printers now too. And, I would be willing to wager that a lot of things that get printed on those 3D printers are probably from Thingiverse or printables, just downloaded files, which are, they're fun. They're good. But, to get onto a site like Onshape where you can get a free trial, and YouTube and the internet is at your fingertips, and you can find so much stuff. So starting to build those building blocks early, as early as high school. Recently, I've been a first robotics mentor out at the Jackson Area Career Center, and they use SolidWorks all the time. And there's kids that are really, really good at SolidWorks, and it's great to see. They're when I started my first job, I thought I was going to be the young guy, but all these old people wouldn't know what they were doing, and I got put in my place very quick. I was like, oh man, I thought extremely wrong. And these people are, 2-3x where I started at. So
Wow.
they're starting to, learn that stuff, but the earlier you can learn it, the better, because you'll get better at seeing, places to use it. And doing the personal projects has helped me out a ton, doing, crazy 3D designs just for fun, because it's fun, right?
Yeah.
So the earlier you're able to do that, the better. And then you'll be able to implement your designs faster. You'll be able to think of crazier things to design. Being, creative is another part of it. And that one's a little bit harder to kind of teach, or I'm sure there's YouTube videos about it too. But, kind of merging your creativity with practical things like CAD, so you can bring your creativity to life. The more reps you get doing that, the better you're going to be. So I have a lot of hope for this younger generation, because they have a lot of tools at their fingertips now. And I probably had a good amount of them that I, didn't get interested in until late in high school. But now, things are available, elementary school, even middle school kids, and they're getting to look at it, and hopefully that sparks that interest even earlier, so they can get much better than me. There's a lot of people out there that I'm sure are much, much better than me, and there are a lot of people that will be, but the earlier you get, the higher you can soar.
Have you heard about this? It's a startup called Backflip. I think it's backflip.ai. I think you would get into this company. You should go check them out. Backflip.ai. It's AI CAD modeling. So you give it a text prompt and it creates a 3D CAD model. And I think the output is STL. I don't know what their trajectory is. If they just want to help people, put things on Thingiverse or something, or if they intend for this to become a serious engineering tool. But just we've all thought about it, right? With the rise of AI, how is that going to change or affect engineering? Anyway, it's an interesting company that people might want to check out. I think they're pretty early right now in what they have, but it'll be super interesting to see how their product matures over time.
Yeah, I'm definitely gonna check that out. Yeah. I was looking into, I heard like you could put large language or AI locally on your computer. I was like, ooh, what is that? I got to learn that, because, how can I get it to watch me and train my own AI to do CAD stuff, right? Like drawings. That'd be great. You could just do some drawings for me.
That would be great once AI can do drawings for us, which it's probably going to happen. I'm sure there are people out there working on that right now. All right, Noah. Well, one more question and then we'll wrap things up. What is one thing that you have done to accelerate the speed of engineering?
Yeah, so it's a little bit counterintuitive. To accelerate, right, is not always working faster and getting a more developed first go at it. Sometimes it's working a little bit slower, taking that extra thought, and then also using your coworkers and the people around you to bounce ideas off of. Fresh eyes, man, they are worth their weight in gold. I'll send, hey, can you come take a look at this? What do you think of this? Can I do this better? They're like, oh, I don't even know what this is, but why are you doing it that way instead of maybe like this way? And you're like, I didn't even think about that. And then you get to chew on that for a little bit, and maybe that's better, right? So fresh eyes and a little bit of back and forth. Now, that doesn't mean like a whole 30-hour-minute sit-down meeting, right? It could just be like, oh, so-and-so's walking by, I'm going to grab them real quick. Hey, check this out for a 5-minute little conversation. That can totally open you up, because I've done it time and time again where I'm locked in, and I've stared at CAD models for a week or 2 weeks, and somebody just says, well, look at over there. Why is it that way? And I'm like, it's been there the whole time and I haven't seen it. So that's a big one of not trying to go too fast, too quick, because in CAD, as I'm sure a lot of people that use CAD know, when you get really, really developed and your assemblies get a ton of parts in them, you make one change to one part and there's waterfall effects that could go, it could only be one part if you're lucky, 2-part change if you're lucky. It could be 3, 4. Assemblies need to change because the parts used all over the place. And so getting a really blocky thing done up first, it's easily adjustable, and then locking that down and taking those baby steps is crucial, right? You want to be the fastest, right? And you want to say, oh man, I can get this long project done in a couple weeks, and I'm just going to show up to the 25% design review with this totally detailed, and they're going to be, wow. And they'll do that a little bit, and then they'll say something like, well, why'd you do it that way? Maybe we could change that a little bit. Oh yeah, we could change that. Definitely. I totally understand why it's better. All of a sudden you're changing 15 parts and updating 15 drawings, and you're pulling your hair out like, oh, why did I do this? So learning that kind of, cruising altitude that you're comfortable with. And over time, as you cruise, you find it, you can start building up slowly. But I definitely made the mistake of jumping too far and just doing this a lot of times. So finding a good cruise point and knowing your optimal speed, and then slowly working to build that up, because you'll catch yourself kind of asking those same questions that other people asked you. Like, well, it's like this now, but what if I flipped it? What if I put it over here or put it upside down? The little things like that. And so you'll think about them ahead of time. And you say, yep, this is why I want it like this and not that way. And so you grab somebody that's walking by and they look at it and they ask you, why didn't you do it this way? And X, Y, Z. And they're like, yep, that makes sense. So finding a good cruising altitude it can help you keep your hair for longer, pulling it out.
I think that's a really important lesson. And I've seen more times than I care to count when exactly the situation you discussed develops, where an engineer shows up to what's supposed to be like a really high level concept design review, and they've got all the details in there, right? They've got all the edge radii and chamfers, and they've got hardware everywhere. And you're like, oh man, I mean, maybe at one point I thought it was cool because, oh wow, it's all done, right? But I've seen this enough times now to where when I see that, I'm like, oh no, we just spent way too much time doing this level of design, because inevitably it's not going to be right? This is like early stage conceptual stuff, and it's never right the first time. That's nobody's fault. It's just never right the first time, and it's part of the process. So, not going too far too soon. And then you mentioned getting advice from other people, have other people look at your design. That's huge. We don't need to do this by ourselves. Most of the time we shouldn't be doing this ourselves. It's not efficient to try and do a complete design just by yourself. You should have someone else looking at it regularly, pointing things out. Why is it like that? Why shouldn't we do it like this? So great answers. Noah, what a delight it's been to catch up with you. It's so nice to see your face and hear your voice. How can people get in touch with you?
LinkedIn, Noah Burke on LinkedIn. That's probably the best way. I don't have a ton of social media, so LinkedIn's the best way to get a hold of me. Love to connect and start growing my network. That's something that I should have rubbed off on me more on my time on Pipeline. knowing a lot of people and having a lot of followers on LinkedIn, you see that kind of cool stuff that everybody's doing. That's another thing. Can't have your head in the sand, right? Just stay in your industry and only seeing things in your industry. It's cool to see things from other industries. There's examples of Pipeline where we've taken ideas from one industry and morphed them into a mechanism that'll work for another one. So yeah, connect with me on LinkedIn. Love to see all the cool stuff you guys are doing.
Awesome. And we'll put a link to your LinkedIn profile in the show notes. Okay. Well, to wrap things up here, we're going to continue a trend and share a review that one of you dear listeners sent to us. Highly encouraged. I would love to get more interaction with users, with listeners. So if you have a suggestion for a guest or a topic that you'd like to hear, please send it over. You can find me on LinkedIn as well, and just send me a message there. You can comment on one of the podcast posts that we've done on LinkedIn. Every week we post about the most recent episode that was released, and you can just comment there, or you can find me directly on LinkedIn and send me a message. But the review that we're going to read today is from Louis D. And it says, just have to mention that I've listened to your podcast for a while now. It convinced me to apply for an engineering program and start that career path within my company. Thanks for all of the time and effort you put into it. Well, thank you, Louis. We appreciate the comment, the review, and thrilled that it helped you make a choice that hopefully benefits your life. And I think that's it for today. So we'll wrap things up here. Noah, thanks again for being on the show.
Thank you so much, Aaron, for having me.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services, visit us at teampipeline.us. To join a vibrant community of engineers online, visit thewave.engineer. Thank you for listening.